chess. Oh, this is a medium. Okay, this is interesting. I have written some chess algorithms. Okay, there's a one indexed, a single dimension containing 3 pieces. You're given 6 integers, A, B, C, D, E, F. A, B denotes the position of the white rook. Okay. So A, B equals white rook. C, D equals white bishop. E, F equals black queen. And given that you can only move the white pieces, return the minimum number of moves required to capture the black queen. Note that rooks can move any number of, yes. Cannot jump over pieces, yes. Bishops can move any number of squares diagonally, can't jump over, yes. A rook or bishop can capture the queen if it's located in a square that it can move to, yes. The queen does not move. Six integers denotes can only move white pieces. Okay, the minimum number of moves. So it's always going to be at least 1, the output. So the queen doesn't move. That makes things a lot easier. And I think in actuality, we're gonna return 1 or 2. Okay. So my idea is see if the bishop can capture in 1 move. Then see if the rook can capture in 1 move. Else, return true. So return 2. The base case is 2, because as long as there's a rook on the board, you're going to be able to capture the queen in 2 moves. The only edge cases we need to figure out is, can one of these other pieces capture the queen in 1 move? And it doesn't really matter which one we do, really. So see if the bishop can capture in 1 move. How do we do that? Basically, we could be a little lazy here. So this is basically accounting for the diagonals of the bishop. We don't need to really worry about like an array out of bounds. But I mean, we should consider potentially not overdoing the iteration. But I'm fine with overdoing the iteration for now. And we probably want to do both diagonals of the bishop at once to keep things simple. We can actually be very lazy here. I want to consider like we could write something to where we just don't care where the bishop is, and then we can improve later once we have an algorithm that works. and then we need to worry about optimization, then we'll do that later. So let's be very lazy, and basically we're gonna do the diagonals of the bishop. So we're gonna, for example, do the bishop is C and D. So in order to kind of simulate doing longest common prefix. All right, nice. I might have already done that. I did already do that. I think I have a video on it too. I could go over the solution later if you want, after you figure it out. But C plus I equals, yeah, go for it. Was it easy for me? Yeah, I would say. Let me longest common prefix. I don't want to open it. I want to try to remember what it's even, what it was even trying to do. Oh, it was an array of strings, and you were trying to go through all of the strings and see which of those strings, or for each of the strings, which one. Sorry, I'm saying like code stuff, but you want to see how much characters of each string match and figure out what the max is. It's kind of funny because like I kind of can't talk in code. So sorry if that gave you a hint. I was just trying to remember the problem. But yeah, I mean, there's usually with these easier solutions, brute force is pretty applicable. It's hard to do better than brute force for easy. Sorry if that's a hint, but it is easy to implement. But yeah, we're looking at the white bishop, and we're gonna see if it lines up with the queen diagonally. So the queen is at E, and D plus I equals F. Then we'll return 1. So let's just try to comment this a little bit. We'll say like bishop X equals queen X. Let's just call it what it is, I think. A is rook X, rook Y, bishop bishop Y, queen X, queen Y. And just for even more readability, we'll just new line need a few, and then we'll do bishop X plus I, bishop Y, and then we'll do queen X, queen Y. Self-documenting code. But we also, so this does one diagonal, which, thinking about it, it's gonna be, I can't really describe it. But in order to do the other diagonal, I guess we minus one of the y's and we plus the other one. So like in theory, if we were to think about it more of a graph, this should be starting at -8, going till +8, and this will be +8. No, this would be -8, going to +8, and then the y. For the x, it's -8 to +8. For the y, it's -8 to +8. But for this y, it's +8 to -8. So that should get us both diagonals. So that's the bishop. We're doing the same thing. Pretty much the exact same logic here. I is -8. I is less than 8. I plus. And then it's very similar. Except it's going to be rook. And we don't apply y for one of the coordinates, and we don't apply x for the other. And so this will be 0 the whole time, and this will be 0 the whole time. And so we're basically just like, for the entire x, is the queen there? For the entire y, is the queen there? Excuse me. And we'll put that here. Otherwise, we return 2. Right, we don't need that comment. It's now obvious. And I guess I'll put rook x, y, bishop x, bishop y, queen x, queen y. Okay, let's try it. I think that it'll be slow, but it should work. Or not. Okay. Let's see if we can visualize this. So I said we could do it in 1, but it should be 2. Oh. Okay, here's an edge case. Alright, there's an edge case. The edge case here is the rook is blocking the bishop. And similarly, the bishop is blocking the rook. So the rule that we missed is pieces can't jump over other pieces. Oops. Okay, in that case, we gotta do a many for loops, which we could probably simplify a little bit. Just to see if we could think of a way. Okay. Yeah, we might need for loops like crazy. I guess we'll be a little bit more respectful. Are we? I don't know. No, we have to be respectful. I equals bishop x. Okay, so it's gonna be x is bishop x. X is greater than or equal to 0. X minus minus. Once we see a pattern developing here, we'll probably try to reduce the amount of code we have, but I don't know about optimizing it. So one thing we can do is if we can say const piece equals, and we'll say const get piece equals xy, and then we'll say if x equals rook x and y equals rook y, return rook. If x equals bishop x and y equals bishop y, return bishop. If x equals queen x and y equals queen y, return queen. Return empty. Okay. Just create a little helper function. So we'll do get piece, and we'll do x bishop y I guess we have to do I. I equals 0. We want to slowly move up and to the left for the bishop. I equals 1. Oh, sorry, I equals 1. Wow, I is less than bishop x. Fine, let's call it x. But what if it's the y that's important? Basically, we don't want to go out of bounds. And we're going to call it y. I plus plus. And basically this will be plus the bishop x plus I bishop plus I. I'll say if piece equals queen, return 1. Else if piece is not blank, break. Something like this. So ideally we would write a function that like takes in a whole bunch of arguments and does all of this stuff for us. So something where I can say like if check if capture queen max is to count, and then we'll do index, and then we'll return x bishop x, y is bishop y, plus index plus index, and then we'll create a function that takes mount and call back and does all of this. Count const coordinate equals callback I, and then it'll be piece, sorry, coordinate dot x, coordinate dot y, okay, so we should be able to simplify all of this and have this if return 1. So this will be, so we're trying to figure out how, sorry, these should be minus and minus. So this is a bishop go up left. And we'll do, just to simplify this, we'll do this, we'll do an array. It simplifies it, but it's not optimal. Again, this is bishop up left. I'm only saying it's up left because it's negative index. Then we'll do bishop up right. In order to go up right, there's probably a way to do this so that you don't have to iterate. Now that I think about it. Okay. Let me put this code somewhere else. Let's see if I can explore this idea of doing this in like big O1. So if, okay, so const and bishop capture queen. The bishop would capture the queen if the queen x minus bishop x equals queen y minus bishop y. So let's think about that. So basically what I'm saying is the queen is capturable here. So the difference between these two needs to be equal. If you go too far up and not far enough over, then you're not on the same diagonal. So okay, if bishop can capture queen, return 1. Return 2 is our base case. We've already discussed this. If const and rook capture queen, the rook can capture the queen if the queen x equals the rook x, or the queen y equals queen y. But then there's the edge case. Can bishop capture rook? And it's very similar logic here. The rook x and the rook y should be y, capital. And then we're gonna say const queen distance. It's a little complicated, I guess, because we gotta see if the queen is in the same direction. Okay. Const dx const dy capture the queen if dx is dy. I'll call it qdx qdy, and then I'll call const rdx const rdy rdx rdy. Const is same direction if math.sign of qdx equals math.sign rdx and math.sign qdy equals math.sign rdy. So basically, are the queen and the rook in the same direction? So we can capture the queen. The bishop can capture the queen as long as it can capture the queen. It can't capture the rook. Or they're not the same direction. Or okay. QDX times QDX is less than RDX times RDX. We already know that RDX is the same as RDY at this point, so we just multiply them both out. So basically the question we're answering here, can we do this bishop capture in one move? I'm definitely getting rid of this old code. We're never gonna use it. So does QDX, QDY, RDX, RDY, can bishop capture rook? The bishop could capture the rook if RDX equals RDY. Are the queen and the rook in the same direction? Sine of QDX equals RDX. Sine of QDY equals RDY. So we can capture the queen if we can capture the queen, and we can't capture the rook, or the two pieces are not in the same direction, or the queen is closer than the rook. That is the logic. And then the next thing is to do it all over again except for the rook. So I'm gonna do const handle bishop. I'm gonna move all this logic into there. Same arguments. I'm doing this just so I can reuse variables. Okay. Okay, so I don't think we need the differential anymore. We might. Rook X, Rook Y. This should be called handle rook. Rook X, Rook Y. Can rook capture queen? The rook can capture the queen if the rook X equals the queen X, or the rook Y equals the queen Y. And then similarly, can rook capture? We go as long as it takes. Yes. We're on our way to a solution though, a big O1 solution. Yeah, for sure. Rook X equals, and rook capture bishop. And try to have the code be self-documenting. Bishop X or rook Y equals bishop Y. So we first determine if they're capturable. They're capturable if they're in the same rank or file. And then are they in the same direction? Maybe we do need dx and dy. The only problem is that they could be 0. This should be b dx, b dy. And ultimately, the only reason this code doesn't end up working is because I copy-pasted something incorrectly. Can rook capture bishop is same direction. I think we gotta do qdx and qdx equals rdx, or qdy and actually, is it that simple? Basically, if qdx is in some direction and rdx is in that same direction, or qdy is in some direction and bdy bdx is in that same direction. So can rook capture queen? Can rook capture bishop? Is same direction. This time is a little bit more complicated. I guess we could technically get away with just doing a square. This is bdx. Wait, oh, yeah. Plus bdy. Let me just new line this, and new line this. I'm gonna do this too, is closer. Queen is closer. I'll do the same thing here. This right here is very lazy, very lazy. I just don't want to figure out which of these have a value. I could do qdx, then QDX, otherwise QDY. And then do map.apps. Am I using these anywhere else? I am. So see if the queen is less than math.apps of BDX, BDX, BDY. Okay, no longer lazy. Let's just run it. Actually, did we call the function? We didn't even call it. Handle, rook. Same arguments. Run. Oh, syntax error. Run it. DX is not defined. UDX, QDY. Can bishop capture queen? Yeah. Okay, we passed those test cases. Let's see if there's test cases we don't pass. Submit it. So we expected 2, but we got 1. We'll do a bunch of logs. Go down here, do a similar log. Cool, run it. So we said that we could do it in 1 move, but we're supposed to be able to do it in 2. Where did this come from? Interesting. Submit it. Let's see what response we get. So what is 1 expected 2, which means that we are detecting that the rook can capture the queen. So maybe one thing that we can do is go to lichess to visualize. And how do I board editor? All right, let's take a look. Is there a quick way to pull these off? No. What's this do? Awesome. All right. Okay, so we start with the white rook. The white rook is at 1-1. And then we do the bishop, which is at 1-4. White bishop. 1, 2, 3, 4. And then the queen is at 1-8. So yeah, we can see we are potentially detecting the rook to take the queen. So we're not detecting something properly with the collision detection. So rook can capture queen, that is true. Rook can capture bishop, which is also true. Are they in the same direction is false. That should be true. So let's take another look. QDX, QDX, BDX, QDY, QDY, BDY. So I don't know if it's like a parentheses issue. Doubt it, but I'm gonna add parentheses anyway. So the QDX is queen x minus rook x. Just for reference, we did it like this, so that the piece we cared about was always on the right. That's important. Okay. Let's submit it again. Okay, is this the same problem? It's not. Okay, so let's set it up. We have a white rook at 0, 1, 2, 3, 4, 0, 1, 2, 3. Excuse me. We have a white bishop at 3, 4. Where do we have it now? 0, 1, 2, 3, 0, 1, 2, 3, 4. And then we have the queen at 2, 5. 0, 1, 2, 0, 1, 2, 3, 4, 5. So we're supposed to say, I have to be doing something wrong here, right? Oh, we're saying it takes 2 moves. So we're not detecting that the bishop can capture the queen. Handle bishop. Queen x minus bishop x. So x, y, x, y, x, y, x, y, x, y. Can bishop capture queen? So, okay. We gotta do this. Basically, it doesn't matter if it's negative or positive. Can we do it sooner though? Yeah, we can't do it here because we need to know the sign to know the direction. Okay. Cool. Got another. It's the same one. It's the same one. Except this time, that's not how you do it. Cool. Wow. We did it. Let's remove the console logs. Since console logs are slow, we'll submit it. Oh, killing it. 100% better than everyone. Yeah, easy clap for sure. Even the memory is pretty good. I'm sure there's ways to optimize it. There's like quite a few micro optimizations. The memory is linear and the runtime is linear. I am curious to see if there's better math solutions than the one. Wow. They just completely golfed. They golfed very hard here. I'm curious if any of the solutions have a loop. I'm gonna ramp it up a bit. Let me see what time it is. 1:21. Let me just look at a few more solutions. I'm curious if anyone did a loop. Let's look at the slowest solutions. Oh. Oh, wow. They created a whole chessboard. Put in what kind of moves these characters can make, these pieces can make. Ooh. Is visible by rook. Is visible by bishop. If it is visible or is visible. Wow. Yeah. Interesting. They even have an in bounds. Wow. Oh. This one's very interesting. That's what I wanted to see. Oh wow. Are people cheating? It's like the same code, except for whatever reason they use a uint8 rather than an array. And oh, it has the same exact comment. Interesting. I wonder if ChatGPT gives this answer or something. Another one. It still runs pretty fast, despite it having all this extra code. Wow, what is everyone cheat? You gotta hit like the 2 milliseconds for people to, or the 3 milliseconds for people to potentially stop cheating. Oh, I can't believe people wrote this. That's crazy. Okay, that's that.